Okay, so the remainder theorem, I saw that what you're doing is that you're using x to the power of 3, this whole equation divided by x minus 2, right? And then I can tell that your remainder over here, you're getting as negative 15
No, that's for the first one.
for the first one, right? Negative 15 for the first one. Yes, you can do that because if you were to divide the x minus 2 from this, you will get negative 15. However, the remainder theorem is telling you that for an equation like this, if I'm dividing, right, and this is actually applying to all the equations as well. If I'm dividing x minus 2, imagine this way, girl, right? X minus 2 is here. You have to multiply for another equation, right, to make up to this. Sometimes you do not have enough. In this case, your remainder is what? Negative 15, right? So basically, if you have, I don't know what this equation is, right? I can always do the long division using x to the power of 3 minus 7x squared plus 4x minus 3 divided by x minus 2, right? I can always get an equation over here. In your case, you got x squared minus 5x minus 6, x squared minus 5x minus 6, right?
Mhm.
So, which means this guy belongs to here, which means that this equation multiplied by x minus 2 minus 15, it's equal to x to the power of 3 minus 7x squared plus 4x minus 3. Okay. So, this is similar with what? Let's say I have 7. Okay. 7 is equal to what? 2 times 3 plus 1, right?
Mm.
So in this case, this 2 is this guy here, this 3 is this guy here, and this minus 15 is this guy here. So it's very similar to just the numerical equations. However, so the remainder theorem states that when px is divided by x minus 8, the remainder is p8, which means that the remainder is this value. So if I'm looking at x minus 2, x plus 3, x minus 8 minus 1, 2x minus 1, x plus 2, essentially what you're going to do is that you're going to let this equal to 0. And what is the x value here?
2,
Good. Let this equal to 0. What is the x value here?
3,
Good. Let this equal to 0. What is the x value here?
x equals 8 plus 1.
Okay. Oh, hold on. X plus 1. X equal to a plus 1, you mean? Okay. A plus 1. Okay. What about this guy here?
X equals 1 over 2.
1 over 2. And this one is negative 2. So what you want to do is that you want to substitute this into the equation. Substitute this into the equation. Substitute this into the equation. And you will be able to find out the actual remainder if you are using this equation to divide this one. That's the essential idea. So instead of doing this way, which you could get the answer, right?
Mhm.
But it's going to be very tedious. Instead of doing that, what I want you to do is that using the magic of remainder theorem, because it's already proven it's always going to work, right? Just using the magic of remainder theorem, substitute a number into the equation, and just get the answer, just like that. Basically, a substitution. Just have to figure out what I did over here. Okay, you good?
Yep.
No, girl,
Yeah.
no problem. So it's gonna save you at least, I would say, 10 minutes for that page. Okay?
Yeah.
All right.
For Claire's work, do you want her to mark it when she like next Tuesday?
Oh, don't worry about clear. So work is already done.
Okay.
Everything's done. Okay, appreciate it, bro.